So I hope you can see my screen. Anybody can confirm that my screen is shared with all? Okay. Okay. So today is the second session for problem solving session for the course Introduction to Probability Theory and Statistics. So have any of you gone through this? So any of you guys gone through this lectures of second week? You can. Okay. So there is only one person. Okay. So the second week was is about. So second week discusses these topics: the random variable, distribution function, cumulative distribution function, probability mass function, probability density function, and distribution function of random variables. So uh, today I will be solving some of the problems related to these topics. But before that, like we need to revise all the concepts of these topics. So I am briefly sharing, I am briefly talking about all the topic in a brief. So yeah, we can start from here. So this random variable, uh, it is a real valued function. So it's a real valued function from uh, from sample set, which is a mapping from sample set to real number. Can you please? Yeah, sure. Okay. सो रैंडम वैल्यू एक रियल वैल्यू फंक्शन है जो कि जो सैम्पल स्पेस है अपना प्रोबेबिलिटी का जो सैम्पल स्पेस होता है उसको मैप करता है इनटू अ रियल it maps it into the real numbers, okay, such that जो जो कि random variable की inverse value है from infinity to a point x, वो belong करेगा to the sigma field of our sample space. Okay, so this probability space is defined by three quantities. First is sample space, then there is sigma field, and then there is probability, right? So there is no confusion about this thing. इसके बारे में किसी को कुछ समझना है? ये चीज क्लियर है? Then can you please explain English as well as people here? Okay. So Ayushi, are you okay? Because there are some people who don't know Hindi. So I like if Ayushi, if you have any doubt, you can ask me and I will tell you in Hindi. I will explain you in Hindi. Okay? Yeah, I am explaining only in English now. So I am assuming that all of you know that what is probability space, which is defined by sample space, the sigma field, and the probability. So now, a real value what is a random variable? So let me draw a figure here. So let's suppose this is our sample space, okay, and there are many events, okay, in this sample space. Now random variable is a real valued function that maps it into the real line, okay. So it will map it on the real value linear function, okay. So it can range from minus infinity to infinity, or from, let's say, a to b. So it can vary from minus infinity to infinity. Now we are saying that if this x inverse from minus infinity to x, where x is included, if this belongs to the f, which is the sigma field, then then this x is random variable on probability space this, okay. So what this thing means, this means that any value, for any value so for any value omega in this set, in the sample space, this function maps this point in sample space, sorry, huh. So this omega, okay. So this means that there are some such omegas which are like, which belongs to this sample space, such that this the value of this random variable on this point is less than small x. So what is this? This is an event. This is an event which satisfies that the omega, that the value of this is less than x. So this is the probability of a of, let's say, this x omega is less than equal to x. So if this quantity, or like this quantity, is found in this sigma field, then only this x is a random variable. Now f is what? F is sigma field where there are few events, okay, few events from the sample space. It may contains all the values from the sample space, and it may contains these few values which are subset of the whole sample space, okay. So I will explain it with an example. If I have created, yeah. So let's suppose there is a sample space which contains only three quantities, a, b and c. So it contains a, b and c, and we define a sigma field. We define a sigma field which is made up of this empty set. Then there is one event which contains only a element. Then there is another event which contains the element b and c. So these two are complementary, okay, these are complement of each other. And then there is the whole omega, okay. Now we created a random variable such that it will take value 0 whenever the omega is a, whenever the value of omega is a, and it will take value 1 if omega is b or c, okay. Yeah, so what this means, So this means that we have this A, B and C. This is our sample space. So we are mapping it such that it is taking values from 0 to 1. So if the value is A, then our x will be 0, and if its value is B, then the value of random variable will be 1, and if it's C, then also the value is 1. So this is how this random variable mapped all these elements on this quantity, ठीक है, on this real line number from 0 to 1. Now what is x inverse minus infinity to x here? So let's suppose there is some x here, okay? So x inverse from minus infinity to x, what this means, that it contains all the value up to this point, okay? So now this is in like this, if x is less than 0, okay, if x is less than 0, then this set is empty because we are mapping from 0 to 1. So if it is less than 0, then this is an empty set, this x inverse. If it is from 0 to 1, okay, from 0 to 1, so it will take only one value, which is a, okay, for it so if its value is from 0 to 1, then there is only one possible value, which is 0, and 0 belongs to a. So this means that there is only one element, which is a. And if it is greater than equal to 1 till infinite, then it will take like all the values which are less than 1, okay? So this includes 0 as well as 1. So 0 corresponds to a, 1 corresponds to b and c. So it will contain all the elements, so which is our sample space. So that's why this x is random variable for defined f, and our defined f was this. If we change this x, let's see, so I will take another random variable. Yeah. Mm. Yeah. But like here, if x is from 1 to infinity, okay, so what is x inverse? Like we are talking about x here, so x is from 1 to infinity, okay? Let's suppose it is 1, okay? So let's suppose that it is only 1, okay, it is equal to 1. So now what will happen? What will be the x inverse minus infinity to 1? So it will include all the points till 1. Okay, this is what minus infinity to 1 represents. So it contains this value 0 and value 1. 0 value is corresponding to this element A, and 1 is corresponds to element B and C. So that's why all the elements will be included, okay? And similarly, if there is any quantity which is greater than 1, let's say 2, so it will contain both the points, and both these points are corresponds to whole set. So that's why if x is from 1 to infinity, it will going to be the whole sample space. Yeah. So now if we define a random variable, let's suppose it's y. So hmm, uh, yeah, there are few rules for writing f. Okay, so first I will explain how to write a sigma field. So f is a sigma field. So it has few properties that should be followed while writing a f. So like I need to be sure. Just wait a minute. So first will be this sigma, this whole sample space should belong to this sigma field. Okay. Then if there is any element A belonging to F, then its complement should also belongs to this sigma field F. Okay. And if there are events, multiple events which belongs to this sigma field, multiple events belonging to sigma field, then union of all these events should belong to F. Okay, so these by these three properties you can make a sigma field. For example, here this is the empty set. So this is the whole set. So this is the first property is satisfied. This is A element, and complement of A set will be B, C, and complement of this will be A. And complement of full set is empty set. Okay. So then second property is also satisfied. Then third property is that if let's see this is A1 A2, then probability of A1 plus A2, what is like not probability that A1 union A2. So this means that probability that any value should contain the either A, B or C. So A1 contains A, A2 contains B comma C. So this is covering whole set. So the probability will be like this, not probability, but this set is complete set. So which is the whole sample set. So which is also part of our sigma field. So that is why it is a proper sigma field. Okay. So this is how you write a sigma field. Okay, so you can define another sigma field which can be probably f1 is equal to empty set, then single set B, then A comma C, and this sample space. So this is another sigma field. This is like, let's suppose this is f0, this is f1, but this is not f0. So this was covered in week 1 lecture, so you can see it from that. Okay. So what we were discussing, if um, oh, so let's suppose I define another random variable which is mapped according to this, that it will take value 0 if x is b, and it will take value 1 if x is equal to a or x is equal to c. So then this here this was this, and our sigma field was empty set. Okay. So, uh, what do you think that this y is a random variable? With respect to f. Okay. So, yeah. So anybody else who didn't get this, like why this is not a random variable, uh, in the another example we got x as a random variable. So let's write the x inverse for this case. So x, not x inverse, y inverse minus infinity to x. Okay. So if this x is less than 0, then it would be empty set. If it is less than uh, less than and equal to 0, then this value will be b, because at 0 this x is b. So that is why if x is 0, then we will get b set. And if it is like greater than equal to 1, then we will get a whole sample space. But now we can see that this is the part of our sigma field, this is also part of our sigma field, but this b set, this is not the part of our sigma field. That is why this y is not a random variable with respect to sigma field f. Okay, because this y inverse minus infinity to x at x equal to 0 gives us this single element b, which is not the part of our sigma field. That is why y is not a random variable with respect to our sigma field. So therefore there are few remarks that so in sigma field there is a largest sigma field which contains all the element and all the combination. Okay, that so any real valued function, any real valued function will be a random variable with respect to the largest sigma field on the omega. Okay, and any random variable x which satisfies or if let's suppose there is any random variable x, so that will satisfy this condition. So if you have given some random variable, then you can easily say that this x inverse minus infinity to x belongs to this sigma field f, if f is given and x is given. So now we will talk about distribution function. So um, a real valued function satisfying these conditions, that this function value is from 0 to 1, as this x varies from minus infinity to infinity, and it is monotonically increasing function. Okay, it will increase, it is not decreasing, it is always increasing. And third condition is if x tends to minus infinity, the function value will be 0, and if it tends to infinity, the function value will be 1. Fourth condition is that f is a continuous function, and if it is not a continuous function, then it will be a right continuous function. Okay, so if it satisfy all these four conditions, any function satisfy these four conditions will be a distribution function. Okay, So now we will talk about what is cumulative distribution function. So for these random variables, we will find the discuss about this cumulative distribution function. Okay, so for that we will need to first understand what is cumulative distribution function means. So we got the idea what is distribution function. Now this cumulative distribution function is the probability that the random variable x will take the values less than equal to small x. This means that for all the uh, values all the values that are in sample space, we can create sorry, this is not R. So for some values in sigma space, sorry, in the sample space, few values will indicates the event that the random like this random variable corresponding to these few events will be less than equal to a given quantity x, then that will be a cumulative distribution function for this x. Okay, so it is indicating few events that uh, whose value will be less than equal to small x. So I will give some examples for cumulative distribution function. So let's say there is an experiment of tossing two unbiased coins. So what will be the possible outcomes? Sample space will be heads, coins, heads, tails, head, and tail. So I will request you guys that if you have any doubt related to the lecture thing, then please unmute yourself and then ask the question, because I cannot parallelly see the chat box. And if there are other questions, you can put on the chat box and I will answer them at the end. Okay. Okay. So now there is a experiment that we are tossing two unbiased coins. So sample space will be that two heads will come, one head and one tails will come, one tail and one head, and two tails. Okay. Now we can define a sigma field for this. So first is it will contain a empty set, then and I am defining now the largest possible sigma field for this sample space. So you can see what is the largest possible sigma field given the sample space. So this is all the single elements. Okay. Then two elements. Now these are all the two events. Now there will be three element events. So I think space is full. So I will write it here again. Empty set, then all the single values, then all the double values, all possible set of double values. Then we were writing the corresponding three sets. Then there will be so I think that is okay. So I think, and then last is this. So I think this is the whole function. So largest sigma field contain values which are 2 to the power n, where n is the number of elements in sample space omega. So there were 4 elements, so there will be total 16, 2 to the power 4 elements in this largest sigma field, that will be 16. So we can count that these are 16. Okay. So now we can define, I am defining a random variable which is the number of heads. Okay. So number of heads we will get when we tosses 2 coins. Okay. So now this so the possibility is that there are 0, there is 1 head, and there are 2 heads. So this corresponding that this value is 0 means that the possible outcome will be tails and tails. So this means that there is no heads. And the case where the where we have one head, then this corresponds to this element. Okay, heads, tails, and tail heads. These events will ensure that there is one head. And if we choose this w is equals to 2, so then this means that it corresponds to the event heads heads. Now if we map this thing inverse function, then what we will get? So if this x is less than 0, so we don't have anything for less than 0, then it will be an empty set. If it is equal to 0 and is less than 1, okay, it is not equal to 1, here it is less than 1, then it will correspond to this situation. Okay, so which is tt. So this t and t. Then if x is 1 to 2, then this will say that this will include this ht, th, and this tt. So all these three elements. And if x is greater than equal to 2 and less than equals to infinite, okay, like, or we can say that x is greater than 2, then it will like it will contain the whole set, okay, whole sample space. Okay, and we can see that this belongs to our sigma field, this belongs to our sigma field, this belongs to sigma field, and this belongs to sigma field. That is why this x is a random variable over our sigma field f. Okay, so I hope this clears something, this example. Okay, so now we will talk about random, no, like the types of random variable. Types of random variable. So there is discrete, then continuous, and then there is mixed. Okay, so discrete value functions look something like this. So this is the cumulative density function for x. So it will look something like this. So for, let's say it's 1, 2, 3, 4. This value is 1. So this says that for the values of x from 0 to 1, if x is between 0 to 1 not included, 0 is included. So if it is from 0 to 1, then its value will be something like, let's say, 0.2. This is 0.2. Then from x, when x belongs to 1 to 2, here it, then the value for our random variable, let's say, is 0.4. 0.4. So this corresponds to fx equal to 0.2. This corresponds that fx is equals to 0.4. And similarly, we can say from if x belongs from 2 to 3, the value will be 0.6, and for 3 to 4, it will be 1. So we can see there are some jumps. These are known as jumps. So discrete events will contain these jumps. Okay. And these jumps defines the probability mass function. Probability mass function for the discrete random variables. Okay. So probability mass function. So how do it looks? Probability distribution function. So it looks like this. At 0, 1, 2, 3, and 4. So now, so at 0, the value will be 0.2, because there is a jump of 0.2 at 0. Before that, we are supposing that it is 0. So at 0, it made a jump of 0.2. So probability at x equal to 0 will be 0.2. At x equal to 1, it makes a jump of again of 0.2. So it will be 0.2. At 2, it made a jump from 0.4 to 0.6. It is also 0.2. So it is 0.2. At 3, it made a jump from 0.6 to 1, which is of 0.4. So this is 0.4. Okay, and like it will remains this from 3 to 4. Okay, and it is, sorry, it is the distribution. This is a cumulative distribution function. Hmm. Yeah, yeah. So it's the like for probability distribution function x. Probability mass function what is cumulative distribution function? It is probability of capital X is less than equal to small x. And what is probability mass function? That the probability that x is equal to xi, okay, this is for a corresponding element at which the jump is happening. Okay, for discrete I am talking. This probability mass function is defined as, so this is probability that for some omega related to this sample space, this x omega is equals to xi. So the exact value where our random variable becomes equal to xi is the probability at that point. Okay. So this so at 0 this our function becomes 0.2. Okay, so the probability that this random variable is 0.2 is that this random variable it is the point corresponding to the element in sample space where this becomes where this x omega will become 0.2. So that's why this point is 0. So at 0 this is there is a probability of 0.2. Similarly at 1 it is 0.2, at 2 it is 0.2, and at 3 it is 0.4. And at 0 it will become, think, so there is no jump at 4, so then there is no probability at x equal to 4. Okay, so now there is continuous. So let's so for this discrete random variables, this probability mass function, so its definition will be that this x exact value where this x becomes xi, and it also follows the property that this p of x is greater than equal to 0, and second is this probability of all the x, like over whole set, the value will be 1. So this is the basic properties which probability mass function follows. So it is for discrete it is probability mass function. Okay, so now we will talk about continuous random variable. So continuous random variable will look like something like this, which is continuous. This is cumulative distribution for random variable x. So it looks something like this, like we can draw it without lifting our pen. We can draw it continuously. There is no break and there is no jump. So no jump here. Okay, in continuous. So here we do not have probability mass function, but we have probability density function, which is defined as like not probability mass function, this cumulative distribution of continuous random variable, cumulative distribution function is defined as minus infinity to infinity fx dx, where this is our probability density function. Okay, so this is our probability density function. So I will give an example for this. So this fx is 0 for x less than 0, it is x for 0 to 1, and it will be 1 for x greater than equal to 1. So this will looks like something like this. This is 1. So from x to 0, it will be 0. So this is this. Then it will be x, and then it will be 1, remain 1. So this is a continuous function. First it was 0, then it will be a function x, and then it will remain 1. Okay, so it's a continuous function. So there can be various functions like this. Okay. So I am not teaching, like I am teaching in a very uh, brief manner, because these all things are talked about in the lecture, and this is the session for discussing the problems. So before that I need to, take you all through these things. So while doing the questions, you like all these things will be in your mind while solving the questions. Then third type of random variable is mixed random variable. So which is at some point it will be continuous, and at some point it will be discrete. It will make some jump. Okay, so something like this. So let's say it's a cumulative distribution function. So if it is like this, and then at this point, let's say 2, it made a jump, and then it remained the same after that, and this is, let's say, 0.6. So from minus infinity to 2, it remained continuous, but after that it made a jump. Okay, and after 2 it remains 1. So it is also continuous from here to here, but at this it became discrete. So this is when it is continuous as well as discrete at some points. It is a mixed random variable. Okay. So another remark I would say, for continuous, no, not like for probabilities of random, for the functions of random variable. For the probability function of random variables. So first is this probability that A is from x to B, and B belongs to this x belongs to B, like this, B is included, then this will equals to FB minus FA, and if it like doesn't involve this B, then it will be FB minus FA minus probability that x is equal to B, and if includes A and excludes B, then it will be FB minus FA plus probability x equal to A. This is for discrete, and for continuous, probability x is from range A to B will be ft dt from minus infinity to B minus it's fx dx from minus infinity to A. Okay, so these points are important. So when this element is included, then we need to add this probability. When this is included, then this is the formula, and if it is not included, then we need to subtract the probability at that element at this when the x is equal to b. Okay, and like for continuous, it doesn't matter if you include this a, if you exclude this b. Like this is similar for this case, similar for case where you include x but do not include b, so it will remain all same, because like for a continuous function, like this is a continuous function, say, so the probability that our element is between a to b is this, but it is at a, so it is a continuous function, so we, the area under this point is nothing, like it's just a this thing. Like if we zoom this point at a, so it will looks like something this, like which is a very small jump if we see, and which is this small jump corresponds to 0. That's why this continuous function, for any continuous function, the probability that our x belongs to a one point is 0. So that is why it doesn't matter if we include a and exclude b, or include both the elements or exclude both the elements, it will remain same. P of the hmm, hmm. No, like it will be from a to b, right? From a to b point. Point probability will be like this one, no? Fb minus Fa. Yeah. That will apply for discrete, but I am talking about continuous. For continuous, probability that the element will take only one value will be 0. Now we will talk about functions of random variable. So, there is a probability space, okay, and x is given. X is a random variable. It is given that x is random variable for this probability space. Now we define a function over random variable, okay. So this will be so this is, so we are not talking about like how to prove that this is a, this is also a random variable, that how y is a random variable. So like for that, like it will need some other type of study. It is a quite depth, like we can go in quite depth, so you can see the lectures or you can follow other element, but it is not important in this subject that you should know that why y is also a random variable. So you can know that y is a random variable, but now what is the distribution of y? What is the cumulative distribution, or the probability mass function, or probability density function for y? So how to calculate that? Okay, for any given function y in the random variable x. So we will, I will explain this with an example. So let x be a discrete random variable. So at each point x, there will be some corresponding values. So it is 1 by 5, 1 by 5. So it is a very easy example. It is just to explain you. So at -2, the probability is 1 by 5. At -1, it is 1 by 5. Similarly, at 0, it is 1 by 5. At 1, it is 1 by 5. And 2, it is 1 by 5. So it is something like this. Probability mass function for this is, okay. So before -2, it will be 0. For -2 to -1, it will take a jump of 1 by 5. This is 1 by 5. From -1, it will take another jump of 1 by 5. So this value will be 2 by 5. At 0, it will take another jump of 1 by 5. So this value will be corresponds to 3 by 5. Similarly, at 1, it will take jump for 1 by 5. It becomes 4 by 5. And at 2, it will take a jump of 1 by 5. So it becomes 1. Okay. So it will remain 1 after that. So this is a something, so it looks like this, the cumulative distribution function for x. Okay. Now, if we define a function y over this random variable x square. So now we have these elements. So we define a random variable this. So let's say so we have these elements in our sample space. Now mapping it using this function, we will get -2 corresponds to 4, -1 corresponds to 1, 0 corresponds to 0, then 1 corresponds to again 1, and 2 corresponds to 4. Okay, this is 4. So if we want to map this thing, then it will look something like this. -2 corresponds to 4 and 2 corresponds to 4. -1 corresponds to 1 and 1 also corresponds to 1 and 0 corresponds to 0. So this is the mapping for using function y. Okay, now what is the probability that y is equals to 0? Which means the y is 0 only when the x is 0. So this means that probability that this small x is equals to 0. So the probability that x is 0 is 1 by 5. Similarly, the probability that y is equal to 1, then there are two cases that x can be -1 and 1. So here, if it is -1 and it is +1, then we can get y equals to 1. So here the probability that y equals to 1 will be 1 by 5 plus 1 by 5, which is 2 by 5. Similarly, y equals to 2 is 2 by 5. Okay, so we can define probability mass function for y such that for y equal to 0, this will be 1 by 5. For y equals to 1, the value is 2 by 5. For y equals to 2, the value is 2 by 5. We can see that all the summation is 1 and these are all greater than equal to 0. So that's why it is a good, it is a valid probability mass function. So this is how to define the function of a random variable. Okay, so this is a discrete example for a discrete event. Okay, what happened? So now we will discuss a continuous event. An example for a continuous random variable. So the probability density function for the continuous random variable is given as this 1 or 0 otherwise. So now we define a function y on the random variable such that if x is less than 0, then the value is 1, and if it is greater than equal to 0, the value will be minus 1. Okay, so now the probability that y is equal to 1 means, so this probability y equals to 1 means the probability that x is less than 0. So x is less than 0, so here we can see that value of so here from minus 1 to 1, the value of the function is 1 by 2. So what can we write? That from minus infinity to 0, fx dx. This will be the probability. Now we can see that from minus infinity to minus 1, we can break it into two: minus infinity to minus 1, then plus minus infinity to 0. So here this is 0 because it is given, otherwise it is 0. So it is only defined in minus 1 to 0. So we can find this value. So probability is equals to minus 1 to 0 fx dx, which is, on finding, you will get that it comes out 1 by 2. And probability that y is equal to 0 means the probability that x is greater than equal to 0, which means that 0 to infinite fx dx. So it is defined only up to 1, so we use it like this. This quantity is 0, and this we will compute, and it will again come out 1 by 2. Okay, so then again this sum of the both events is 1, and both is greater than equal to 0, so it is also a probability mass function. This is a here y is py is probability mass function of continuous random variable x. Okay, so now, like, so these are the few things that I want to go through before we will solve few problems. So now I will share some questions, and I will give you you guys time to solve them, and then I will solve the question. Okay, so you can see the screen, right? So okay, so this is the first question. So x is a random variable, and the CDF is given like this, that the value of fx is 1 when x is greater than equal to 1. Its value is 1 by 2 plus x by 2 when x is between 0 to 1, and if it is less than 0, it is 0. Now you need to find probability that random variable x is equals to 0, given that this x is less than equal to 0.5. So I will give you some time, and you can solve this question. So the question is that we are given a random variable x. CDF is CDF is no P of sorry P of x equals to 0. Yeah. There is the use of this formula. Yes, x2/3. Any other answers in the chat box? Okay. Okay, so let's now discuss how to calculate this. So we are given that we need to find that Px is equals to 0 given that x is less than equal to 0.5, which this like we can use the Bayes theorem and we can write it that x equals to 0, this event intersection with the event that x is less than equal to 0.5 and then divided by the probability that x is less than equal to 0.5. Now on this this is 0, this is 0.5. So this event is saying that probability should be for this point. Okay, this is saying that we will include all these points. So intersection of less than 0.5 and x equal to 0 will be probability that x is equal to 0, and then another is this probability that x is less than equal to 0.5. So now x is equal to 0, so the function is our function at 0 is 1 by 2 plus x by 2. So x is 0 here, so probability that x is equals to 0 is 1 by 2. So this upper part will be 1 by 2, and now the another is that x should be less than equal to 0.5. So 0.5 will lie in this part, so this will be 1 by 2 plus 0.5 by 2, which will be 1 by 4. So 1 by 2 plus 1 by 4 will be 3 by 4. Okay. So yeah. Yeah. You can do that, but then you need to say that 0 to 0.5. Not from 0.5 to 1, because it is saying that less than equals to 0.5. Okay, so we need to do it until 0.5 only. So only from 0 to 0.5. So it will be the value at the 0.5. So it will be, it is 3, it will be 3 by 4. So which comes out to be 2 by 3. Okay. So now there is a second question. So it is also of the same kind. So it is a x is a random variable, and now we are given a probability density function. So it means that x is a continuous function. No, sorry, x is a discrete function, because we are given a density function. Sorry, it's a continuous function. So this is given as, okay. So this is given as, if x is less than equal to 1, the norm of x, then the function value is cx square, and otherwise it is 0. Now we need to find the probability that uh, x is greater than equal to 1 by 2. So try to solve this question. Break the what? Because you need to find the value of c. So like to like, what are the properties, what is the probability property for a probability density function, that fx from minus infinity to infinity fx dx, it is 1. So it is defined only from minus 1 to 1, because norm x means that for 1, either for 1 or minus 1, it will be, the value will be cx square. So if you will open that bracket for minus x, it will come out that x will be greater than minus 1, and it is less than 1. So this means that this function is defined only from minus 1 to 1. Okay, yeah. So like here I will solve this question. So this probability density function is given as cx square less than equal to 1 and 0 otherwise. So if we open this mode, so like if x is positive, then it will remain as this, and if it is negative, then it will be something like this, which can be written as this, that x is greater than minus 1. So we get a range for which this function is defined. So from minus 1 to 1, this function will take a value cx square, and for other points it will be 0. Okay, so now try to solve the question. So this, we know the property of probability density function, that from minus infinity to infinity fx dx is equals to 1. But as from minus infinity to minus 1 plus minus 1 to 1 plus 1 to infinity, we can break it in three parts. This value is 0 and this value is 0. So this fx dx from minus infinity to infinity will become minus 1 to 1 fx dx, which is cx square dx minus 1 to 1, which is cx cubed by 3 minus 1 to 1. So this will be c by 3 minus c by 3, which is 2c by 3. And we know this is 1. So 2c by 3 is equal to 1, which means c is 3 by 2. Okay. So now we need to find the probability that x is greater than equal to 1 by 2. So which means fx dx from 1 by 2 to infinity. Now again we can break it into two parts, 1 by 2 to 1 plus 1 to infinity, and this is 0. Then we need to calculate this. So this is again cx cubed by 3 from 1 by 2 to 1. So this will be 1 by c by 3 minus c by 8. C by 24. So you can bring c by 3 and here it will be minus 1 by 8. So c by 3, 7 by 8. Put the value of c, which is 3 by 2 into 1 by 3 into 7 by 8. So the value is 7 by 16. Okay. So you just need to follow the correct definition of each part. Okay, so x greater than 1 by 2 means that we need to integrate it from 1 by 2 to infinity, but the function is defined only in minus 1 to 1, and after from 1 to infinity the value is 0, so this becomes 0, and then we need to solve only from 1 by 2 to 1, and we calculated, it came out to be 7c by 24, but we use this fx dx from minus 1 to 1 will be 1. From there we calculated the value for c, which is 3 by 2, and then put it in here and it comes out 7 by 16. So you need to have all the basics clear for solving this problems related to random variables or cumulative distribution function. So that's why you need to first clear the basics of probability. Okay. So yeah. Hmm. Hmm. You can this can be a one way that you can assume them as a lower limit and upper limit, but here this function was defined something like this, that x is less than equal to 1 and otherwise it is 0. Okay, so otherwise means that it will be minus 1 to minus infinity and 1 to infinity. Okay, like it will be more fundamental if you do like this, otherwise it is also fine, there is no issue with your method, but you should know that why the value is 0, because it is given that the density function is 0 in those part. So this is the next question. So here we have this probability function. Okay, like y square. So, so this is also similar to the previous one, but I now want you guys to solve this question. So it is a mixed function, right? Before, like not mixed. Oh, it is. Sorry, it is not mixed. It is not mixed. It is continuous. Yeah. So you can calculate the PDF. So by differentiating it, you will get the probability density function. The exact value at that point and the jump they will make at that point. So cumulative density function is the sum of all the events what had happened before that particular event. So let me explain this. So cumulative distribution function for discrete type is something like this. Then it will make a jump at this. So this is, let's say, x1, this is x2. So cumulative density function is something like this, but probability mass function will be that at x1 this value will be equal to this jump. So let's say j1. So it is j1 and this value is j2. So at x2 this value will be j2. Okay, so this here corresponds to j2. So this is correspond to the jump they make at that particular point. Yeah. But it's a continuous function, so that's why for continuous function we like they gave the cumulative density function. For discrete, generally they won't give the probability distribution. Like they will give probability mass function. But if they will give, you will understand it because it is, like it will be defined something like that. Oh, sorry, something like this. Like x less than equal to 0. If x is from 1 to 2, this will be 1 by 3. Fx 2 to 3, then its value will be 2 by 3, and if it is greater than equal to 3, this is 1. So you can easily see this probability mass function that at 0 it is 0, at 1 there is a jump of 1 by 3, at 2 it is also a jump of 1 by 3, and similarly at 3 there is a jump of 1 by 3. So this is the probability mass function you can get from this fx. Yeah, you just need to subtract it from the subtract the earlier set of cumulative distribution function from this successive set. Okay, so the question was this. So let me explain. So, so let's first try to plot this graph for the cumulative distribution function. That's y. So this is saying that from 0 to 1 by 2 it is y square, so it will be something like this. At at 1 by 2 the value of y square will be 1 by 4, but it is saying that here this 1 by 2 is not included, but then it is saying that at value y equals to 1 by 2 and above, included here is 1, okay, and before that it is 0. So we can see from minus infinity to half it is a continuous function, but at 1 by 2 it made a jump of 1 by 2, of 3 by 4. Okay, so here it becomes discrete. So it is a mixed function. Okay, so probability uh, uh, that anything is that x is greater than 2 is will be 1, greater than equal to 1 by 2 will always be 1. So now we need to find the probability that our x y is from 1 by 4 to 3 by 8. Okay, so am I audible? Okay, so this 1 by 4 is 0.25, which will come somewhere here, and 3 by 8 is 0.375, it will come somewhere here. So we need to find the probability that our y belongs to this. Okay, so we are given this probability function. So this from 0 to 1 by 2, so this is between 0 to 1 by 2, so f this cumulative density function will be y square there. So this probability density function will be dfy by dy, which will be 2y. Okay, so um, uh, so this 2y is the probability density function. Sorry, fy. So probability density function came out to be 2y. So now we need to find this probability that it is from 1 by 4 to 3 by 8. So in continuous it doesn't mean that if you want to include this point, okay. So it is similar to probability that it is between this point excluding 1 by 4. So it is fx dx from 1 by 4 to 3 by 8. So which is y square 3 by 8 to 1 by 4. So it is 9 by 64 minus 1 by 16, which comes out to be 5 by 64. Okay. So it is when you integrate this, then it will become y. It is 2y, na? So when you integrate this, it will become, if you take this 2 outside, it will become y square by 2. So this 2 will be cancelled from this 2. So it will be y square only. Yeah. Okay, I hope you all understood this question. So, like whoever asked the earlier question, that is why we need to plot this CDF kind of thing. That's why we don't want to see just the upper limit and lower limit, because here this 1 by 2 is not included, here it is included. So this was like easy question. So if I asked it uh, if it belongs from 1 by 4 to 1 by 2, if 1 by 2 is included, and if it is excluded, then it will be two different probabilities. So we need to take this thing in mind, that every time you are solving the problems related to distribution function of random variable, or you need to find the probability that this what is the probability that random variable has this value, then always try to map this cumulative density function. Always and always try to map this cumulative density function. It is 5 by 64. Yeah. So I think this is the last question for this session. So x is a continuous random variable with probability density function defined as 1 by 2 into e to the power minus norm of x for all x belongs to R, and we define a function on this random variable which is x square. Then you need to find the cumulative density function for y. Okay, this is function of random variables. So how to find distribution for a function of random variable? Y is function of random variable. So I will explain this one. V inverse of y. हाँ, you will use that theorem, but or without that also you can do it in a simple way. Like that is a one way which is explained in the lecture, uh, like the lectures of NPTEL lectures. And another way is like if it is given y equals to x square, then we need to find that y is equals to is less than y. We need to find this cumulative density function for y. So this probability, so this is given as x square. So what is the probability that x square is less than y? So this can be seen as x is less than equal to root y. Okay. So now this function is or what can you write? Sorry. Just a minute. So it is this y is less than capital Y. So this we can write this as y as x square. So now the probability is it is less than root y, that root y should be less than equal to x. So this is similar as probability uh, of any x is less than x. So given this we are given this probability. Hmm. Hmm. So I am also confused. It is. Hmm. It is. So before that I wrote that. Hmm. So this probability x square is less than y. Probability that x is less than root y. So now we know this thing. This can be written as fx dx from minus infinity to root y. Okay. This can be written as this. So we know this value. This is given. So we can write this as 1 by 2 e to the power minus norm of x minus infinity to root y into dx. So now this so we have this root y. Okay, so y cannot take values, cannot contain negative real number values. So y should be always greater than equal to 0. Okay, so this py is equals to 1 by 2 e to the power minus root y dy from 0 to 1 by 2. Sorry, 0 to infinity. Okay, and when you solve this, it will come out to be that for y greater than equal to 0, this is, when you solve this thing, it will come out to be 1 minus e to the power minus root y and 0 otherwise. Sorry, it is y. No, it is root y. Yeah, it is root y. Sorry. And it is x. This is also x. So you all are helping me in this assignment. So yeah, so when you solve this thing, now it is correct, I guess. E to the power minus norm of x now. So it will open up, this is norm of x, but here we are taking only positive values, so it will come out as x only from 0. So for x greater than equal to 0, this norm x will be x. Okay. So now it will be 0 and minus root 1. Okay, then you need to, I think, norm that vector. So okay, then you need that gy by dy. So okay, like I will explain this part in the next class, as it is also running out of time. So I am also getting confused in this question. Yeah. So like it will be from 0 to root y, right? So y will only be taking positive values. So it will be e to the power minus x. Yeah. So this but how this 2 is cancelling out, I need to check, or maybe this is 1 by 2 here also. I need to verify this, like this is the right answer or not. Because it comes out, this integration will be minus 1 by 2 e to the power minus x. So if we put root y, then it will be minus e to the power root y by 2 minus, when you keep this 0, it will come out minus 1 by 2. So this will be 1 by 2 minus e to the power minus root y by 2. So so where is this 2 has gone? So I need to check whether this is the right answer or not. So I will tell you in the next class. Okay, so because from here it is from this calculation it is coming out that it is 1 minus e to the power minus root y by 2 for y greater than 0 and 0 otherwise. So now if there are any doubts, like there are some things, so now so all these videos, we are three TAs from for this NPTEL sessions. We are discussing the doubts and we are trying to solve different questions in these sessions, and we all three are recording our videos and these will be uploaded on the YouTube. So we will share this YouTube link, or you can just search our, there is a channel from our name. So my channel name is Kritika Kadwasra. So you can directly go there and you can see that I have uploaded the week 1 video. So every one of us is going to upload these videos. Okay. Yeah, sure. Yes, you need to can you see if you can present your screen? Can you check? Or it is on, not on your screen? Try to do that now. Yeah, I will share the link of my YouTube channel. Yeah. No, all the three are different. We will discuss. So I have shared the YouTube link for my for the first video that I have uploaded. So you can go there and you can subscribe that channel, I guess, or you will be able to. Yeah, I shared the link for the video for the first week lecture, and I will share this channel link also. Yeah. So can you? Yeah. Shridip, you can share. So I have uploaded the YouTube video. So please, any of you can try to click on the link and see, like you are able to access the video. Yeah. Okay. Video signal. So this is week 2, right? So like we are not allowed to discuss, this week's assignment questions. So in the next week, I will be able to discuss these questions. Yeah. Oh yeah, like it is like small things, but you can try to Google it. What is a binomial distribution? So it is quite easy. So you will be able to solve this. It is not taught in the class, but maybe in the next weeks it will come. Yeah. So okay, I will then drop off, and we will meet on next Friday. Yeah. Uh, so all of you can, please copy that YouTube link, because when I am leaving this, ending this video, then you are not able to access this link. So I can also share the link from the other sessions also. So these are the links from other sessions. So the one easiest way is to going to all these videos and then subscribing the channel, because each of one will be putting our videos in these separate channels which are made by our own names. So it is some policy, so they can also evaluate that we are taking all the classes. So we are three TAs, and I have shared three YouTube links for all the previous three classes. And yeah. So right now I'm not aware of the book particularly related to the distribution type of problem, but the book which is referred by, I think, Professor Dharmaraj in the lecture, it is good. You can follow that. Or it is not about to follow any type of book, just to solve a lot of problems. So I will share this in the next class if I came to know about this. There is a book which has a lot of good questions related to probability. It so it is because of this mathematical side, right? So they are, yeah. Mm. So I will try to find a book which is related to only few topics, random variables and everything. Okay. Yeah. Okay, okay guys, then see you in the next session.